Alright, so here we have another example that we want to solve. It says that I want to solve the triangle ABC if I'm given angle B as well as sides A and C. So the first thing you want to do if you're not given the triangle drawn for you is obviously draw the triangle. Now I'm going to label my triangle going ABC as I move around the triangle in a clockwise fashion. I know that angle B was given as 73.5 degrees, and I know that side A is 28.2 feet, and remember sides go across from their angles, and side C would be 46.7 feet, again across from angle C. So here I have again, sides and an angle. I don't have enough information to be able to use the law of sines, so I have to start out if trying to find if I'm trying to find all of the angles as well as the sides of this triangle, I have to start out using the law of cosines. So that's the first thing that we're going to do. That's going to be our first step here, is to use the law of cosines. And I'm going to use it to find side B. So the law of cosines for that says if I have side B squared, that's got to be equal to side A squared plus C squared minus 2 times AC times the cosine of angle B. So we're going to plug in our information into this and into my calculator. So I'm going to make sure that I take the square root, but let's just write it all out. So B squared has to be equal to the 28.2 squared plus 46.7 squared minus 2 times those values, 28.2, 46.7 times the cosine of 73.5. And remember, this is degrees. So in my calculator, I'm going to plug it in, take the square root, and we'll come back and we'll get a value. So taking the, using the calculator, taking the square root, I should find that the side B is approximately 47.2, as you can see from my calculator. So B is equal to 47.2. And we'll just write that on our triangle over here. I now know all 3 of the sides to the triangle. I get to move and I get to try to find the angles. So since we have a known angle and its side, we can use the law of the law of sines as the known ratio and set up a proportion to find an angle, one of the other remaining angles. Now remember that ugly little ambiguous case that we noticed when we did the law of sines? We have to be careful that we don't inadvertently try to solve for an angle in this triangle and kind of end up in a case where I might end up with an ambiguous case. So the way to avoid that is to, when we are at this point, I have 2 angles, right, that I'm trying to look for. We want to choose the smallest angle to apply the law of sines on, and that's going to alleviate that ambiguous case for us. So we want to use the law of sines on the smallest angle remaining. Smallest angle. Now how do I know what the smallest angle is? So is it angle A or is it angle C? Well, I hope that you said that it's angle A, because remember that the smallest angle is always going to be across from the smallest side. So that's how I know that I'm going to choose angle A. So let's finish off using the law of sines on angle A. So my known ratio would be side B divided by the sine of angle B equal to side A divided by the sine of angle A. So we have the information we need in here. Side B would be 47.2 feet divided by the sine of 73.5. That's equal to side A of 28.2 feet divided by the sine of angle A. So doing a little algebra here, we are going to cross multiply. I end up with the sine of 70, let me rewrite this differently. I'm going to say 28.2 times the sine of 73.5. That's equal to 47.2 times the sine of A. Now, it's the sine of A that I'm trying to isolate, so we're going to divide both sides by 47.2. That gives me that the sine of angle A is equal to this fraction over here. And I'm not going to do anything with it until the very end, so I have 28.2. Let me just rewrite this, times the sine of 73.5 divided by 47.2. Don't forget, though, I'm trying to solve for angle A, and when I do, the operation that I'm going to perform is I'm actually going to take the inverse sine of both sides. So when I take the inverse sine of both sides, that's going to give me the angle A that I'm looking for. So in my calculator, I'm going to take the inverse sine of everything you see in that set of parentheses, and when I do, rounding to the nearest decimal place, I end up with 34.9 degrees. So make sure that you can get that on your graphing calculator as well. So what do I know now? I know that angle A is 34.9 degrees. And it would be really easy. I could go back in and I could use the law of sines one more time if I wanted to. But I don't. I actually think that I'm going to just go ahead and use the fact that the sum of the angles in a triangle, so the sum of the interior angles in a triangle has to be equal to 180. So angle C has to be 180 minus angle B, which was 73.5, and angle A, which was 34.9. So angle C has to be equal to 71.6. And that's how we're going to apply the law of cosines when we are asked to solve a triangle, meaning I have to come up with all the angles and all the sides. Please take away from this, however, that if I start out with the law of cosines, like I did here, to solve for a side, as soon as I move into applying the law of sines, I want to start by choosing the very smallest angle so I don't end up with an ambiguous case scenario.